Laboratory activity number 4. Coefficient of linear expansion. The activity aims to determine the coefficient of linear expansion of aluminum, brass and copper. Coefficient of linear expansion is defined as the change in any linear dimension per unit of linear dimension, per degree rise in temperature. It is designated with symbol A. A solid possesses molecules of ceaseless motion. This body has a kinetic energy of translation, rotational and internal vibration that, when it is exposed to a higher temperature, the molecular activity increases. Any internal vibration that occurs requires more space for the movement of the molecules. This results in the increase of linear dimension, such as length, width, and thickness of a solid metal. To solve for coefficient linear expansion. Mathematically, coefficient linear expansion is equal to delta L over L sub O times delta T, where A equals coefficient linear expansion, delta equals change in length, L sub O equals length at the initial temperature, delta T equals change in temperature. These are the materials and equipments used in the experiment. 1 set linear expansion apparatus. 3 pieces of metal rods, brass, copper and aluminum. 1 pieces of foam insulator. 1 set of thermoplastic elastometer tubing. 1 unit of laptop. 1 set of rotary motion sensor. 1 unit of steam generator. 1 piece of tube clamp. 1 piece of evaporating dish. 1 pair of gloves. These are the actual photos during the experiment. Data and results. These are the results for the table 1. The materials: the 3 rods, which is copper, brass, aluminum, the L in millimeter is given, and the delta L, the change in length, and delta T is the change in temperature, is given by the data studio while doing the experiment. Next, for the table 2, coefficient of thermal expansion, the coefficient of linear expansion times 10 raised to -6 is given on the table for the copper, brass, aluminum, which is the true value, while coefficient linear expansion, experimental, is our own computation given the datas coming from the data studio, and use the coefficient of linear expansion formula, which is equal to delta L over L sub O times delta T, and for the percent difference we use true value minus experimental values over true value times 100. Observation. For the observation, we observe that aluminum has the highest thermal expansion, followed by brass and copper. Conclusion. Lastly, for the conclusion. Therefore, we conclude that aluminum has the highest thermal expansion based on the percent difference that we get. The heat passed through the aluminum rod is faster and efficient other than the other rods, which is copper and brass. That's all, thank you for watching.